So here is a great work from the student on rhyme schemes and prosody in Sanskrit. Yeah, I don't speak the language, but this work is super impressive, and there is a lot of analysis of the language and also connection to mathematics. I want to briefly go through this. I don't really understand the grammar and phonology of Sanskrit, but this work, this writing is super clear, super mindful. I do appreciate all your hard work and yeah, a lot of dedication to the course. Really appreciate that. Here are 3 pages of this document, and there's more on the pronunciation, the phonology, and some examples, super clear. This is an analysis on the first verse of a rap, which connected hip hop and rhyme scheme. In the class, I showed the rhyme scheme in English, Chinese, and Japanese. These are the 3 languages that I speak. But I do appreciate a lot of information on other languages, and because I don't speak those language, I cannot see for them, but there is rap. You can rap in any language as long as you speak that. And I've heard rap in French, in Korean, and yeah, Sanskrit is definitely a very suitable language for rap. I'm sure any language can rap, right? So here I want to make some comments on the mathematics, the relationship with of the language, linguistics with math, because I happen to have some knowledge on math myself, and the work of math is on the last page here, where the author mentioned binomial. Sorry, let me see. Okay. So let me go to this one. This is the last page on math, where I want to make some comments and hope it will help you to understand this more. And if you want to complete this work, I hope it can provide you some feedback and help. Okay, let me present. This is the part the student wrote. Here, he mentioned the binomial theorem. Yeah, it's here, binomial theorem, and also Fibonacci sequence. So for binomial theorem, here is the formula, I believe. So he used this a plus b, the third power here. Sorry. So this can be expanded into this form, and also if the power is 4, can be expanded to this. Actually, there is a minor mistake because there should be some coefficients before this. So this should be 1, 3, 3, 1, and here should be, as stated here, there are some coefficients. Let me write it down. It should be 1 plus 4 plus 6 plus 4. So there are some coefficients in front of those terms, but it's just a minor mistake. I would say it doesn't matter that much in terms of the concept here. I do appreciate the concept, and the math is suboptimal. But I want to make some comments to make the math clear here. Here is the equation for binomial theorem. Okay, if the power is n, you can expand this to this form, and you can tell this is the pattern of A and B, and this is the coefficient. Okay, the coefficient, I'm writing this in this form, but in other formula you can write it as kn. Okay, sorry. So this is the same it means the same thing. It's just different annotations. Some people write it is C and K. When I was a student, we learned in this form, but I also see other books or literature use this. Okay, so they are the equal. What does this annotation mean? It means we choose K from N. Okay, we choose K terms from N terms. So if N is 5, K is 2, means if we have 5 like items here, and we choose only 2 of them, which we will choose 2 from the 5. So how many combinations will be, right? So we can choose these 2, or we can choose these 2. So I need two out of 5. Okay, so this is what the formula means, and how to compute this. There are some equation. I'm not going to say that mention this, but here in this example we have n equals to 4. Okay, so actually say 4 0 is 1. So there is only one combination if we choose 0 from 4, and say 4 1 is 4. Okay, so for example, I have 1 2 3 4 items here, and there are only 4 possibilities, right? I can choose either this one, 1 2 3 4. So there are 4 possibilities, and say for 2 would be, actually the formula would be 4 times 3 divided 2. Okay, so it's actually 6. There are 6 possibilities, 6 combinations. And C, okay, I mean right here, okay, C 4 3 is equal to C 4 1 is 4. Okay, so there is some symmetry here. C 4 1 equals to C 4 3, and C 4 4 equal to C 4 0. Okay, and it's 1. Therefore, if you substitute those coefficients into this formula, you can say, okay, for this 1, 2, 3, 4, 5, for these 5 terms, the coefficients will be C 4 0, coefficients is 1, is 1, and here it should be C 4 1 is 4, and here C 4 2 is 6, here C 4 3 is 4, and C 4 4 is 1. Okay, so this coefficients 1 4 6 1 4 1 is 4 1. Okay, it's the same here. Okay, as the author wrote. I hope it makes sense. But let me just erase those to spare some space for me. Okay, so since we know there are some coefficients, and but here the author still said we can actually adding them together, and we get this number 16. Okay. So what does this 16 means? 16 means so actually we can add them together to get for 16, and there is another way to deduct this number, which would be, okay. So here we have 4, right? The power is 4, which means we have 4 positions. 1, 2, 3, 4. Okay, we have 4 positions, and there is A and B. So here A means the short syllables, and B is the long syllables. So we have 2 possibilities, A and B, right? and we have 4 positions. So here, at each position, we can choose either A or B. Right. And here we can also choose A or B, A or B, and A or B. So how many combinations will this be? So this can be A or A B or A B B A B. So how many are these? Actually, this is computed by this formula, right? Here is two possibilities, multiplies 2, multiplies 2, multiplies 2, which is 2 of the 4, power of 4 is 16. Okay, so this is where this 16 comes from. Okay. So here are some basic knowledge on combinatorics, combinatorics. Okay. Hope this is clear. And here I want to continue transit to Fibonacci sequence. So what is Fibonacci sequence? It is here. Okay. So this is Fibonacci sequence. Okay. So let me write it down. It should be 1. Oh, sorry. 1, 2, 3, 5, 8, 13, etc. Okay. The rules and how we derive this sequence would be any number any number would be the addition, okay, of the first its previous 2 numbers. So 2 plus 3 is 5. 3 plus 5 is 8. 3 plus 5 is 8. 2 plus 3 is 5. 1 plus 2 is 3, right? And 5 plus 8 is 13. So this is how this whole sequence is derived, and we can continue with this infinitely. 8 plus 13 is 21, right? So we can continue with this sequence infinitely, these integer numbers. But here, actually the author provides us another way, or another I would say another route, right, to how we view this Fibonacci sequence. Not only from this number, the number theory, but also we can combine this with some moral patterns. Okay. Actually, I never thought about this way. I think this way should exist, but I haven't learned this before, so this was somehow very eye-opening for me, reading this word, how it combines moral with Fibonacci sequence, and exactly how you derive Fibonacci sequence from this perspective of moral combinations. Okay. So here actually you can see if so it means we have short, right? Short syllables and long syllables. Short we use S, and short syllables is a placeholder. It takes one place, and long syllables takes 2 placeholders. Okay, because long syllable is long, and we see it takes 2 of the positions, and short syllable only take 1 position. So here it means, so here the syllables means if we have this, let's take this for example, if we have 3 positions, what combination we can have, right? Remember, the short syllable take 1 position, the long takes 2 positions. And here you can have 3 short, right? Short, short, short. or the first is short, but the last is long. The long syllable takes two positions, so we only have short, long. Or I can take the first two as long, the last one is as short. Okay, so we have three combinations listed here. Okay, and let's say we have four syllables, 5 syllables, 6 syllables. We can write down all those combinations as such. Okay, as a enumerated list here. But how do we derive it mathematically, or how do we prove that this sequence is really a Fibonacci sequence, right? For now, we only have the first 6 examples, but we cannot promise if we have 100 syllables, will it still follow the rule of Fibonacci sequence. So here it's demands some proof. Okay, some proof. So I will give you a proof that I think should be easy to understand, and that uses a method called induction. Okay. Oops, sorry. Mathematical induction. Okay. So this is a very preliminary but also very important method of mathematical proof or mathematical logics. The induction, the process would be, we know that if we have one syllable, we have one patterns. Okay, if we have 2 syllables, we have 2 patterns like this. So for one syllable, so we use the annotation T, which means total, okay, to denote. So T1 is 1. T1 means we have one syllables. T2 is 2. T3 is 3. And T4 is 4 syllables is 5, right? It's 5. And yeah, so on and so forth. So we use T. So let's see if we have n minus 1 syllables, and then there will be T n minus 1, right? Patterns, not number of patterns. So here we already know our initial condition, right? Our initial condition is T1 is 1 equals 1, T2 equals 2. And now we are going to derive the induction formula for Tn minus 1. So let's see, we know what is Tn minus 1. Let's see, we know that, let's see, we already have n positions, okay? The many positions, we don't know how many are these. Okay. Let me write it better. We don't know how many are these in between. So let's see, we have n minus 1, okay, placeholders. And we know how many patterns are here of short long would be T n minus 1, right? So our next step would be, we want to add one more position, okay? Like here, it's 1, 2, 3, 4. We want to add one more position to make it n. So I see the one more position we're adding is here. And now in total, there will be n placeholders. And when we add this one more maybe this is not good. When we add this one more position here, there will be actually two situations, okay? Two different situations here. The first one would be this extra one syllable or extra one position can be short, okay? So this one is isolated, and we will use one short syllable to place on this, okay? So this one is short. Then how many combinations are here? We know this is short, and this entire combination will be Tn minus 1, right? And the second situation is that because we also have a long, right? Short is 1, long is 2, and we can actually make the last two syllables equals to long, which means now I'm going to combine those last two syllables to make it one long syllable, okay? Then if this pattern is fixed, how many probabilities or how many combinations are here? It should be, so we are taking these two syllables and the left, okay? There will be n minus 2 positions left. So here in the second situation, the possibilities would be Tn minus 2. Okay. Therefore, we deduced this mathematical induction. Okay, this formula is recurrent. Formula is Tn equals Tn minus 1 plus Tn minus 2. Okay, so this is the formula we derive from this situation. And this is also the formula for Fibonacci sequence, okay? So the definition of a Fibonacci sequence is any number is the summation of the first, its previous two numbers, okay? And this is the proof of this sequence, of the moral patterns of short and long syllables, okay? So hope this clarification will be helpful for you to understand this word, and also if you want to complete this work and adding more details to this, make it more rigorous, probably. Yeah, I just hope it is helpful, but this is really a great work. I do appreciate the work the students put into this. Okay. Thank you for watching. Okay.